Humanity has always dreamed of finding a second home among the stars. For decades, science fiction writers and dreamers have looked at the red planet and imagined a future where humans live, work, and thrive on another world. But are we finally on the verge of making that dream a reality? Right now, we are closer than ever before. With the rapid development of reusable rockets, ambitious timelines from private space companies, and renewed interest from space agencies, the race to colonize Mars has officially begun. The goal is no longer just to visit, but to stay. But Mars is not Earth. It is a frozen, radioactive desert with a thin atmosphere and no breathable air. The challenge isn't just getting there, it's surviving in an environment where everything is trying to kill you. So, how will we actually live on Mars by 2040? What technologies will we need to breathe, eat, and return home? Can we transform the red planet into a habitable world? And is it really possible to build a self-sustaining city on a dead planet? Before we can live on Mars, we have to survive the trip there. And make no mistake, the journey itself is one of the deadliest challenges in human history. Mars is, on average, 140 million miles away. To put that in perspective, the Moon is a 3-day trip. Mars is a minimum of 6 to 9 months inside a metal can floating through a cosmic shooting gallery. Timing is everything. We cannot just launch whenever we want. We have to wait for the planets to align, quite literally. This launch window opens only once every 26 months, meaning if you miss your departure date, you aren't just delayed a few hours, you are grounded for over 2 years. Once the ship leaves Earth's protective magnetic field, the crew enters the danger zone. Deep space radiation is a silent killer. Without proper shielding, cosmic rays will tear through the ship's hull and into human DNA, increasing cancer risks dramatically before the astronauts even arrive. Then there is the issue of gravity, or the lack of it. Months of weightlessness will cause bones to lose density and muscles to wither away. If we don't solve this with artificial gravity or rigorous exercise, the first colonists could arrive on Mars too weak to even stand up. And finally, there is the arrival. Slowing a massive spacecraft from 12,000 miles per hour to zero in a thin atmosphere is what engineers call the 7 minutes of terror. If the heat shield fails or the retro rockets don't fire at the exact millisecond, the mission ends in a crater, not a colony. To conquer the distance and the danger, we need a vehicle unlike anything built before. For half a century, space travel was defined by small capsules and disposable rockets. That approach is too expensive and too small for colonization. The solution that changes the equation is Starship. This isn't just another rocket. It is the largest flying object ever created by human hands, dwarfing the Saturn V that took us to the Moon. But size isn't the revolution here. Reusability is. In the old era of spaceflight, rockets were thrown away after a single use, like flying a Boeing 747 from New York to London and then crashing it into the ocean. Starship changes the paradigm. The booster is designed to return to the launch tower, where it is caught by massive mechanical arms, refueled, and launched again within hours. This drives the cost of launch down from billions to millions. However, the most critical piece of the puzzle happens before the ship even leaves Earth's orbit. A fully loaded Starship is too heavy to reach Mars in one go. The solution is an orbital ballet. The passenger ship launches first and parks in low Earth orbit. Then, tanker variants of the ship launch, docking with the passenger vessel to top off its tanks. This orbital refueling is the key that unlocks the solar system. It ensures that when the ship finally departs for Mars, it leaves with a full tank, maximizing speed to reduce radiation exposure and ensuring there is enough cargo capacity to build a life once we land. The biggest problem with Mars isn't getting there, it's getting back. A starship needs massive amounts of propellant to escape Mars's gravity and return to Earth. Bringing that return fuel with us from the start is physically impossible. The ship would be too heavy to launch. This leads to the most critical technology for colonization: In-Situ Resource Utilization, or ISRU. In plain English, it means living off the land. We don't bring the fuel, we build a gas station on Mars. The atmosphere of Mars is 95% carbon dioxide. For us, that's suffocating. For a rocket scientist, it's a gold mine. We have already tested this technology on the Red Planet. The Perseverance rover carried a device called MOXIE, a gold-plated box the size of a car battery. It successfully sucked in Martian air, split the carbon dioxide molecules using intense heat, and puffed out pure, breathable oxygen. But breathable air is just a bonus. The real goal is rocket fuel. Using the Sabatier process, colonists will combine that atmospheric carbon dioxide with hydrogen. But where does the hydrogen come from? Mars doesn't give it up easily. To get it, we have to become miners. The colonists, or their robotic precursors, must locate massive subsurface glaciers of water ice. They have to drill through the regolith, melt the ice, and electrolyze it. Then, using the Sabatier reactor, that hydrogen is mixed with the CO2 to produce water and methane, the exact fuel Starship engines run on. This is the tipping point of the entire 2040 vision. Automated robots will likely be sent years in advance to set up these fuel plants. Before the first human boots even touch the red dust, the return tanks must already be full. If the fuel plant fails, the colony doesn't just lose its ride home, it loses its life support. But survival is not just about oxygen and fuel, it is about the mind. Once the adrenaline of the landing fades, the crew faces a new, silent enemy: the isolation. Imagine standing on the surface and looking back at Earth. From here, it isn't a world anymore. It is just a star, a pale blue dot. You can cover it with your thumb and make everything you have ever known, your family, your history, every human being who has ever lived, disappear in an instant. That distance breaks something in the human psyche. You are not just far away, you are disconnected. A simple "hello" sent to Houston takes up to 20 minutes to arrive, even at the speed of light. A reply takes another 20. There are no live conversations, no instant help. If an emergency happens, the crew is on their own, and the daily life is not the sci-fi dream of glass domes and sweeping vistas. Those glass domes we see in movies would let in lethal doses of radiation. To survive, the colony must be buried. We will live in lava tubes, massive underground caves formed by ancient volcanoes, or beneath meters of piled dirt. The reality of 2040 is that to reach the stars, we will have to become cave dwellers again. For months or even years, you will not feel the wind on your face. You will not smell rain. You will sleep in a windowless room, eat processed algae, and work in artificial light. The darkness, the confinement, and the crushing knowledge that there is no easy way home will test the human spirit more than the rocket launch ever did. For all its harshness, Mars is not just a prison, it is a canvas. Today, survival means huddling in caves and hiding from radiation. But long-term, scientists imagine reshaping the entire planet. One extreme idea is to nuke the poles, detonating nuclear weapons high above the Martian ice caps. The goal isn't to blow the planet apart, but to vaporize frozen carbon dioxide, thickening the atmosphere and warming the surface almost instantly. A gentler vision involves gigantic orbital mirrors floating in space. These would focus sunlight onto selected regions of the planet, slowly melting the ice, releasing gases, and turning a frozen desert into something that feels a little more like home. None of this will happen overnight. It is not a 5-year plan. It is a 500-year plan. But every habitat we build in 2040, every ice deposit we map, and every gram of fuel we make is a first brushstroke on that canvas. The rockets are being built. The fuel chemistry works. The habitats are on the drawing board. The real question isn't, can we do it? It is, who is willing to pay the price? Because the first wave of Martian settlers will almost certainly be signing up for a one-way trip. They will be the architects of a world they might never see fully bloom. Would you take that seat if you had the chance? Join us next time as we explore more mysteries of the universe.